हेलो स्टूडेंट्स, वेलकम टू बीआरके केमिस्ट्री एकेडमी। यहाँ ऑर्गेनिक केमिस्ट्री को सिंपल और इजी वे में सिखाया जाएगा, स्पेशली नीट जी और अदर कॉम्पिटिटिव एग्जाम्स के स्टूडेंट्स के लिए। इस वीडियो में आप सीखेंगे SN1 एंड SN2 ऑर्गेनिक रिएक्शंस को लॉजिकली समझना, इंपॉर्टेंट एग्जाम ओरिएंटेड कॉन्सेप्ट्स, शॉर्टकट्स, टिप्स और स्मार्ट सॉल्विंग मेथड्स, और नीट एंड जेईई की प्रीवियस ईयर क्वेश्चंस। सब्सक्राइब करो बीआरके केमिस्ट्री एकेडमी को और ऑर्गेनिक केमिस्ट्री को मास्टर करो इजी वे में। डियर स्टूडेंट्स, फर्स्ट ऑफ ऑल, what are nucleophilic substitution reactions? Nucleophilic substitution reactions are reactions where a nucleophile replaces a leaving group from an alkyl halide. What are nucleophiles? Nucleophiles are chemical species that donate a pair of electrons to form a chemical bond. Or in other words, we can say nucleophile means nucleus loving, which likes positive centers. Some examples I have mentioned here: hydroxide ion OH-, cyanide ion Cn-, halide ions Cl-, Br-, I-. Next, coming to below reaction, bromide ion acts as a leaving group. Hydroxyl ion acts as nucleophile and attacks the carbon of alkyl halide, that is methyl bromide, to form an alcohol called methyl alcohol. There are two main types of nucleophilic substitution reactions: SN1 and SN2 reactions. SN1 stands for substitution nucleophilic unimolecular. This reaction takes place in two steps. You can remember this by imagining a bulky boy taking two steps. We use the example of a bulky boy because alkyl halides with bulky alkyl groups usually follow the SN1 mechanism. SN2 stands for substitution nucleophilic bimolecular. This reaction occurs in a single step. You can remember this by imagining a small boy taking one quick step. The small boy represents a smaller alkyl group. For example, methyl bromide undergoes nucleophilic substitution by following the SN2 mechanism. Now, let me explain about SN1 mechanism clearly. SN1 mechanism का full form substitution nucleophilic unimolecular reaction है. Here, unimolecular represents rate of reaction depends only on the substrate concentration, not on the nucleophile. The rate law is written as rate equals to K into substrate. This means that when the concentration of the substrate increases, the rate of reaction also increases. SN1 reactions are commonly shown by tertiary halides because they can form stable carbocations easily. A well-known example is tertiary butyl bromide. बच्चों, ध्यान से सुनो, SN1 reactions generally tertiary halides शो करते हैं क्योंकि ये बहुत easily stable carbocations बना लेते हैं और stable carbocation बनने की वजह से reaction आसानी से हो जाता है. The SN1 reaction mechanism involves two steps. First step is formation of carbocation, where the carbon-halogen bond breaks and the leaving group departs. For example, in tert butyl bromide, bromide ion leaves to form a carbocation. This step is called the slow step or rate determining step because it requires more energy and decides the overall rate of the reaction. After the carbocation is formed, the step 2 is nucleophilic attack of carbocation, where the nucleophile attacks the carbocation quickly. This is called the fast step. One more interesting point to note here is type of solvent you are using for the reaction. SN1 reactions are favored in polar protic solvents such as water, ethanol, and ethanol water mixtures because these solvents stabilize the carbocation and the leaving ions, making the reaction easier. Observe positively charged carbocation is surrounded by OH- ions. This has been asked in one of previous year NEET exam. बच्चों, ध्यान से सुनो, SN1 रिएक्शंस में पोलर प्रोटिक सॉल्वेंट्स जैसे वाटर और एथानॉल में फास्ट होते हैं क्योंकि ये सॉल्वेंट्स कार्बोकेटाइन और लीविंग आयंस को स्टेबलाइज कर देते हैं. जैसे जब NaCl वाटर में डिसॉल्व होता है तो Na+ और Cl- आयंस अलग हो जाते हैं.
वाटर मॉलिक्यूल्स अपने ऑक्सीजन साइड से Na+ आयन को सराउंड करके स्टेबलाइज करते हैं और हाइड्रोजन साइड से Cl- आयन को स्टेबलाइज करते हैं। इसी तरह SN1 रिएक्शन में भी सॉल्वेंट मॉलिक्यूल्स कार्बोकेटाइन और लीविंग ग्रुप आयंस को स्टेबलाइज करता है, इसलिए रिएक्शन और इजीली हो जाता है।
Coming to stereochemistry, the carbocation formed is very important in SN1 reactions. It has planar geometry with sp2 hybridization and bond angles of about 120 degrees. Since the carbocation is planar, the nucleophile can attack from either side of the positively charged carbon. Since the carbocation is planar, attack can occur from both sides, producing both configurations of the product. Therefore, SN1 reactions often form a racemic mixture, which is a mixture of two enantiomers. If the nucleophile attacks the carbocation from front side, R form is formed. Similarly, if the nucleophile attacks the carbocation from back side, S form is formed. I hope you understood SN1 reaction and its mechanism. Next, we will move forward to SN2 reaction and its mechanism. Now, let me explain about SN2 mechanism clearly. SN2 mechanism का full form substitution nucleophilic bimolecular reaction. Here, bimolecular represents rate of reaction depends on both the substrate concentration and nucleophile also. In this reaction, nucleophile replaces a leaving group in a single step. For example, in methyl bromide, CH3Br, the bromide ion Br- acts as the leaving group, while a nucleophile like OH- attacks the carbon atom. The nucleophile attacks from the backside of the molecule at the same moment the leaving group leaves. So the reaction happens in one concerted step without forming any reaction intermediate. But it forms transition state molecule called pentacoordinate transition complex, in which carbon-bromine bond is half broken and carbon hydroxide bond is half formed. SN2 reactions occur best in polar aprotic solvents such as acetone, DMSO, and DMF, dimethylformamide, hexane, etc. Because these solvents do not strongly surround the nucleophile and allowing it to attack the carbon of methyl bromide easily from backside. Now the question is, why nucleophile is attacking from backside? Because already more electronegative bromine is present in front side and repels it. Understood? Next is an important feature of SN2 reactions is stereochemistry inversion, called Walden inversion. Since the nucleophile attacks from the opposite side, the arrangement of atoms flips, similar to an umbrella turning inside out in a strong wind, often called the umbrella flip. Here, inversion of configuration takes place. That is, if you take R form, you will get the product S form. And if you take S form, you will get the product R form. Overall, we can say inversion product predominates in SN2 reaction. I hope you understood SN2 reaction and its mechanism. Next, we will move forward to some important MCQs. Let me explain some important MCQs asked in previous year NEET and JEE and other competitive exams. The rate of an SN1 reaction depends on A. Nucleophile concentration, B. Substrate concentration, C. Solvent only, D. Temperature only. You can pause the video and work out on the options before I reveal the answer. Correct option is B. Substrate concentration. A slightly tougher version of the same question would be like this. Rate of SN1 reaction increases when A. Concentration of tertiary butyl bromide is reduced by half. B. Concentration of tertiary butyl bromide is doubled. C. Concentration of hydroxide ion is decreased by 50%. D. Concentration of hydroxide ion is doubled. The correct option is B. That is, concentration of tert butyl bromide is doubled. Question 2. Which intermediate is formed in SN1? A. Carbocation, B. Carbanion, C. free radical, D. transition complex. Answer A. carbocation. By increasing the difficulty level a little, the question would be hydrolysis of tert butyl chloride in aqueous medium. The slow step involves the formation of which reaction intermediate? A. tertiary butyl carbanion, B. tertiary butyl free radical, C. tertiary butyl carbocation, D. pentacoordinate transition complex. Correct answer is C. tertiary butyl carbocation. SN1 reactions prefer A. polar aprotic solvents, B. polar protic solvents, C. non-polar solvents, D. basic solvents. आंसर इज बी पोलर प्रोटिक सॉल्वेंट्स. अगर इसी क्वेश्चन को थोड़ा और डिफिकल्ट बनाया जाए तो वो होगा a substrate undergoing an SN1 reaction reacts most rapidly in which of the following solvents? A. dimethyl sulfoxide DMSO, B. acetone, C. ethanol water mixture, D. hexane. Correct answer is C. ethanol water mixture. Thanks for watching. If you enjoyed this video, please like, share, and subscribe to BRK Chemistry Academy for more chemistry concepts, shortcuts, and exam tips. Keep learning, keep growing, and stay connected with us for more exciting chemistry videos. See you in the next class.